Welcome to Biology My Passion. I am Soumya Harikrishna. We have been learning the chapter Work and Energy. Work concepts are over, so let's see some practice questions from work. Read the activities listed below. Reason out whether or not work is done in the light of your understanding of the term work. So what is the understanding we have? Work to be done, two things to be satisfied. One, there should be a force. Second, there should be displacement in the direction of force. So Hemant is swimming in a pool. Yes, in that case, Hemant is applying a force and also there is a displacement for him, so he is doing work. A windmill is lifting water from a well. Yes, windmill is applying a force, water is lifted up to a height h. A donkey is carrying a load on his back. But here, the donkey is carrying a load at its back, but it is not moving. So there is no displacement. So this is not work done. A green plant is carrying out photosynthesis. Again here no displacement, so no work. An engine is pulling a train. Yes, engine is pulling, applying a force and the train is moving. Food grains are getting dried in the sun. No displacement, no force. A sailboat is moving due to wind energy. Yes, wind energy is applying a force and as a result the sailboat is also moving. Is work scalar or vector quantity? Work is a scalar quantity. Work done is measured by, you know that work is equal to force into displacement. The SI unit of work is joule. When the force is applied on a body is increased, the work done on it. So work done or force applied on the body increase. Work is directly proportional to the force applied. So if you are increasing the force, then the work done also will increase. What should be the angle between force and displacement to get maximum work? There are three types of work done: positive, negative and zero. Positive means force and displacement both in the same direction, so the angle is 0 degree. Whereas in this case, force is in one direction, displacement is in the opposite direction, angle is 180 degree. Zero work means force and displacement are perpendicular to each other, that is 90 degree. So this is based on the formula of trigonometric formula f cos theta. So looking at the value of cos theta, 0 is having the highest value, that is positive. So this turns out to be 0, this is a negative value. So this is the highest. So angle between force and displacement to get maximum work is 0. What should be the angle between force and displacement to get minimum work? So minimum work means what? The force and displacement are perpendicular to each other, 90 degree we get the minimum work because the work becomes 0 in this case. What should be the angle between force and displacement to get negative work? It should be 180 degree. So because force and displacement are in opposite direction. The amount 1 joule is equivalent to, that is when 1 Newton force is applied on an object to displace it through 1 meter, then the work done on that object is called a 1 joule. How much work is done when a force of 15 Newton displaces a body by 8 meter in the direction of applied force? This is a direct question. Force is given 15 Newton. The displacement is also given 8 meters. It is in the same direction. So W is equal to F into S. So we get the answer 15 into 8. 120 joules is the answer. Calculate work done in lifting 100 kg of water through a vertical height of 10 meter. So whenever we are talking about lifting something vertically, that means against the force of gravity, we can take the formula mgh. Work done is equal to mgh. So here m is equal to, we know that m is equal to 100 kg, that is the mass of the water. Then we know g is 9.8 meter per second, so here it is given meter per second square, acceleration due to gravity, and h is given 10 meter. So we have to multiply mgh, substituting this 100 into 9.8 into 10. So it becomes 9,800 joule. A porter carries a load of 500 Newton for 10 seconds. The work done by him is. But here we know, since he is carrying a force on his load on his head, he is applying a force on the load above, but he is not moving, no displacement. So here F is equal to 500 Newton, but S is equal to 0. So work done is equal to 0. No work is done by a man pushing a wall, because when he is pushing a wall, he is applying a force F, but there is no displacement. So we can say that work done is equal to 0. 8,000 joule of work is done. So W is given 8,000 joule by a machine to lift a mass of 100 kg. Mass is given 100 kg vertically upwards. Calculate the height to which the mass is lifted. So here we can take the formula mgh, because it's vertically lifted, and we have to find out h. H is equal to work done by mg. So what is work done here? 8,000 joule upon mass is 100 kg into, they are asking us to take, it is 100. So 10. So it is 8 meters. The displacement or the height through which it is lifted is 8 meters. Find out the work done. So we have to find the work done. When a force of 40 Newton, F is equal to 40 Newton, displaces a body through 5 meter, S is equal to 5 meter in the direction of the applied force. Again, it's a direct question, F into S. Each time you have to write the formula, then substitute 40 into 5. 200 joule is the work done. 60 joule of work is done when a force of 20 Newton is applied on an object. So work done is directly given, that is 160 joule, and the force is equal to 20 Newton. Calculate the distance through which the object moves and state its direction. So here we have W is equal to F into S. We have to find out S. So we have to bring this W to the denominator, W by F. So 160 by 28. This is 8 meter. So work is done, a force of 20 Newton is applied on an object. So usually it is in the direction of the force. Person of mass 50 kg, mass is given 50 kg, climbs a tower of 72 meter, vertical height is given. So again, work done, we can say that W is equal to mgh. Here they are asking us to take g as a 10 meter per second. So we can find a W with a 50 into 10 into 72. 36,000 joule is the work done. A magnetic crane lifts a mass of 1000 kilogram. Mass is equal to 1000 kilogram through a vertical height, h is equal to 50 meter. Calculate the work done, g is equal to 10 meter per second. So W is taken as mgh. So 1000 into 10 into 50. So 5 lakh joule. Joule of work done. Work is given 1000 joule by a machine to lift a load through a vertical height of 10 meter. Calculate the weight of the load lifted. So we know that work done is equal to mgh. Here we can take g as 10. So 1000 is equal to mass into acceleration due to gravity into height 10 meter. So mg is equal to 1000 upon 10, 100. Therefore, weight is equal to 100. It is equal to 100 Newton. At a certain angle to the ground, suppose this is the ground, an object is thrown and it is going up in a curved path and falls down to the ground. So this is the initial position. Here is the final point of the path of the object. They both are on the same horizontal line. What is the work done by the force of gravity on the object? So if this is the direction of their movement, but force of gravity is perpendicular to that. You can see this angle is perpendicular. So if the angle between F and S is 90 degree, the work done is considered as 0. So here the work done is 0. I told you the formula is F cos theta. Theta is the angle here into displacement. So F into cos theta is 90 degree here into S. Cos 90 is equal to 0. So the answer is 0. Mass of 10 kg, M is given 10 kg, moves from a point A to B on the table. Suppose this is the table, it was the initial position. It moves from this position to this position. So this is position A, this is position B. If the line joining A and B is horizontal, what is the work done on the object by the force of gravity? Again, the force of gravity in this case is cos theta is equal to 90 degree. So 90 degree value is 0. So the work done is again 0 in this case. The work done by the force of gravity on a satellite moving around the earth justify. So what is the work done by the force of gravity on a satellite moving around the earth? Okay, so earth has the gravitational force, but we know that any point here it is 90 degrees. So in a circular path, basically the work done is always 0, because the centripetal force or force of gravity of the earth moving around the satellite, this angle is 90 degree always, so the work done is 0. If you understood all these concepts well and the numericals found useful, please share with your friends, like and subscribe to my channel Biology My Passion.